Thank you, Digvijay. So, yeah, I want to talk about the mental model that you should have when you are working with GraphQL. I've seen some people compare it with REST. Some people take it that there would be performance issue. One question was from him that how do you deal with optimizations of data? I mean, if resolver just gets you what the user is asking for, how do you optimize all your resolvers? How do you optimize your DB calls? So it's not only optimizing the network, right? So there are a lot of confusion I see there. So I want to kind of clarify that and also talk around the server side as well as the client side on how you should maybe approach that pieces. So a little bit about me. I do design engineering at Geo. Yeah, engineering managers. Okay. So you can find me on Twitter at Manish Alexan. You can just come say hi or ask any questions regarding this, anything regarding React, React Native, GraphQL. I'd be happy to answer. So just a refresher, what is GraphQL? We have already seen something from Gobinath, and you might have also read about it. Just before that, how many of you are front end as well as back end? Who's front end? Raise your hands. Oh, most of you are front end. Nice. Back end? Okay, you guys do all. Nice. Great. So, so my talk is tailored towards both front end as well as back end. So we'll, I mean, if you have any questions in between, you can stop me. So yeah, just a little refresher around GraphQL. It's a query language specification for APIs with solving problems around underfetching, overfetching, having inverting the control to the client, strongly typed, giving you free documentation, all those stuffs, right? But I'd like to call it as wishful driven development. Why I would say that? Think of it. It's important in very subtle ways, right? You start to think about your APIs in a way that is ideal for your client or for your business, right? You don't think should I really be working for just my home screen where maybe you need user, you need comments, some other profile data. You don't think in those terms. What you're thinking is what could be my ideal API for that client? Should it be multiple APIs? Should it be just one API? Should it consider extra data that has to be sent over the network, or it should just send what is required for that particular page, right? So you think around what is the perfect API for your client. So it's more wishful. And if you see, it's also wishful in terms of what the client wants, right? Client says saying, I want just a user and projects. I don't want anything else. Client can wish for whatever is required for that particular screen or that particular component. So, and you don't have to worry about multiple endpoints. It's just one single endpoint that you are always going to hit. Plus, with all the documentation of GraphQL Playground that he showed you, you can also understand in real time what your server supports with all the typed messages around it. So, yeah. Anything I'm missing here? Yeah. Cool. So there are some confusions around what GraphQL is. Is it really a database? Is it, I mean, how does it give me everything that I'm asking for? How can it be dynamic that I only ask for user name and email and it's not really going to my database and picking the whole user object? So GraphQL is a thin layer in between your any kind of implementation that you have. The implementation control is still on you. You can still talk to any kind of database. It can be MongoDB, it can be Postgres, it can be even a file on your server, it can be anything. All you have to worry about is resolving for particular fields that the client is asking for, and you are good to go. And I've seen many people comparing it with relational DBs that when you talk about graph, there is a relationship, right? So there's a user and there's a relationship with comments and post that is done by user, right? I'm talking about a hypothetical example of, let's say, a blog. So the relationship here is determined by how you define your schema. We'll discuss about schema also going forward, but I just wanted to clarify on this piece that GraphQL is just a specification that implementation is completely in your control. You don't have to, I mean, it's not a framework, it's not a library. You don't have to abide by a particular way of doing things. I mean, there is a way of doing things, but then it's not a library. It doesn't enforce anything on you. Implementation is completely up to you. So the question that you had around if I'm just asking for user name, is it really going to my DB and getting the whole user object and just returning me the name, right? It's not like that. You can still have the control, and you can just make sure that the DB call that is happening, it's just querying for name, select name from user table, right? I mean, in MySQL terms. So yeah. So let's talk about client side. Currently we do two things, right? Get and post. I mean, we have other things. We have put, patch, delete, but then who cares? No one. I mean, these days we don't have that. Mostly it is around get or post. We just for any kind of queries we do get, any kind of mutations, any kind of side effects on the server, I do a post. Correct? So the comparison on the GraphQL side is queries and mutation. For anything get, you now have to think queries. Anything post, you have to think mutations. Cool? So this is what the structure looks like. Are we on structure? Yeah. So there's an operation type. Where you are looking at query is can also be a mutation, like we discussed, and then you can have a name. This is only for you to refer to it. There are variable. This is like you passing argument into your get or post APIs, and then you're asking for things. So earlier in REST, you would have an endpoint saying users, your api.com/user, right? You don't know what it will give you. It might give you just the ID, name, and email ID, or maybe date of birth. You don't know. Till the time you have not hit the API, you don't know. Here you know what you're going to get. You can, I mean, I might have to show it through code, but if you just do a control space on while typing, it will give you a type completion because this is completely strongly typed. So you know what that entity of user comprises of. Not only that, it also tells you if it is of what type. Is it a string type? It's a integer type. It's a Boolean type. You also know all of that. So you can be type safe on your client side as well. Yeah. Okay, cool. So this is a comparative get query might look like on the GraphQL side. You have something called query, and then there's a name. You want to query for a particular episode, and you are querying for the hero and the name of the hero, right? So this is from a Swappy example. Swappy API. It is Star Wars. How many Star Wars fans? No one? Okay, one. Oh my gosh, you don't watch Star Wars. Okay. So yeah, so basically consider that hero to be just a user. You're just querying for name, so you're getting a name. That's all. So this is a one-to-one example of if you had a REST API get of a user with the name. So yeah. And then a post example would look like this, where you have a mutation, exactly same structure that is being followed. There's some arguments that you're passing, and then you're asking back for stars and commentary. Yeah. Okay. Any questions till now? No? So we have covered get and post, what we do on REST side. So this can be any client side query. This doesn't have to be a GraphQL client. You can even use Postman. You can write your own fetch to do this because GraphQL doesn't deal it separately. It's still a HTTP call, and you can still pass it as a body of whatever you are looking at. So you can pass the whole query or mutation as a body of as a get as well as a post for mutation and query. So the next thing, important piece here is arguments, which was previously described in query, but then I just want to reiterate. Like in get, you pass query parameters, right? You say myapi.com status equal to 1, 2, something, ID equal to 1, 2, and then you get the user with ID 1 or 2, right? So here you can do the same thing by passing it inside in this kind of a syntax. Sorry. And these IDs can also be provided to each field. So these arguments are not specific to one particular top level query name. You can pass it to, like you're seeing here, you can pass it to height as well. So these arguments can be passed to anything. Now it's up to the server how it understands that, and we'll see in the server side how it understands these things and what can you do with these. But then this is a way of you passing dynamically some data to the to your API. And the other piece is variable. So in your post request, you are mostly passing some kind of data that you want to have a side effect on your server side. Like if you're creating a user, or you are creating a user, or making maybe writing a post or writing a comment for that user. So you'll pass that in the body, right? You'll pass with ID, with some comment or whatever the post message is. Similar thing you can do with variables here. The variables are, if you see the variable here is JEDI, and you pass it. So variables are true for obviously query as well as mutation. So you can pass it inside your query for hero. So this also brings some problems of its own, right? In your REST API calls, you are mostly dealing with just one structure. You cannot have multiple structures. So if you are asking for user, you are just gonna get back user. You cannot ask user and post all at once. You'll have to most probably make 2 API calls. Here, if you can ask for a user or maybe multiple user in the same query, you are gonna hit with the same name exception, as in you'll have the same name, so you cannot. So there are something called aliases, so you can obviously alias it with a different name. So you can use aliases here. The other piece is, let's say you have a website where you're gonna show 2 hero characters side by side. How are you gonna query them? In most probably you'll have to write the same query twice with just one difference of maybe the ID or maybe the name separately that you're asking. So for that, there is something called fragments, which are units in GraphQL. You can just write fragment once for a particular type and then use it in any of your queries. This is what is happening, and there's a left comparison and right comparison here, in which I am passing comparison fields on character, where I'm asking for name and appears in like in which movie and what are the friends of this character. So I'm asking for that, yeah. Yeah, one more important piece that I want to cover in the client side is, this is again part of GraphQL specification. There's something called directives, in which you can not only use variables to dynamically query for something, where you provide a particular variable for, let's say, a user ID, right? You can also have something like include here. Include only if the friends, this variable is true or false, right? So you can change the structure of your query based on certain conditions. So directives helps you with that. GraphQL comes with exactly just 2 directives, but then you can write your own directives as well. GraphQL comes with include and skip, but like I said, you can write your own directives as well. One more interesting piece on the client side, what you can do is, the previous one was just making the API calls, right? The comparison with the rest. The other piece is what Gopinath also was talking, is the local data management. Right now, we make API calls with our API client, and then there's a separate data management completely for us, right? We have to understand the data that is coming from my API client and then somehow store it, which is still meaningful to me. And in most cases, we don't worry. Whatever we are getting from an API, we just store it, and wherever I have to use it, I just use it. I don't make any connections between them, right? So if my homepage is requesting for a user, let's say it's me, so the name would come, some email ID would come, but then some other page, if I need that thing again, I'm most probably gonna make another API call, which will return me exactly the same thing. So should I do that? Should I really request for the data that is already with me, right? So for that, exactly same thing. I mean, you can do that also with Redux or MobX. It's called data normalization, but it's not that straightforward to achieve. That is one piece. Plus, you see the differences, right? There's a API client separately, and then there is this data management separately. So it's like a whole DB layer that you are maintaining in your app for management of your data. So erstwhile state and data managements, the most popular ones are MobX and Redux. While Redux is just a functional way of doing. There's a global store which takes in some actions. Reducer understands the actions and modifies the state in a different way. It's a straightforward state machine. There's a previous state, there's some action, previous state plus action is a new state, correct? While MobX deals in a observable and observer pattern where you get computed values whichever you are observing for. And with Apollo, there you can, so I mean, this is not specific to Apollo client. You can have this with any other GraphQL client. It's just Apollo provides this in a very straightforward way there, and there are not multiple GraphQL clients at this moment that you can use in your React or any front-end applications. There's new one on the block which is called URQL, but it's not mature enough, I'd say, at this point in time. So state management with that is not there yet. What Apollo provides you is this. You can make queries to your GraphQL endpoint, your REST endpoint, maybe some local data as well, and it just sits as a data layer for your application, which lets you do both the things. It lets you query for the network calls. I mean, it acts as a network layer as well as the data layer. It lets you query for your network as well as for your local data cache as well. And the other piece is so mostly with GraphQL, you cannot use GraphQL if you don't have a GraphQL endpoint. I mean, where do you start? You first need a GraphQL endpoint, right? And if your company or if your product has not yet written any of the GraphQL endpoints on the backend, how do you still use it? How do you still have the benefits of GraphQL? There's something called client-only schema from Apollo that you can write, and it's exactly the same way you can write your schema on the client side, defining whatever you want. There are two important pieces. There's a type definition and resolver, which is, again, exactly same concept what you do on the server side. In type defs, you define the schema that I have a user type, I have a comment type, I have a post type, and then I have resolvers for this. I resolve for user, post, and comment, correct? And this is what is happening here. This 4 or 5 lines of code will help you achieve that. What you get in return is nothing fancy like Redux with time travel, but you get this. You get the free documentation for your data layer. And mind you, this doesn't have to deal with GraphQL endpoint. You can still have a REST endpoint. And you still will have complete free documentation for what you're using on the front end side, which gives you the types. It also gives you what all you can query, and there's also something new called Explorer in GraphQL Playground, which will let you play with it. I mean, experiment with what all data you can get in what all ways you can get. So it's pretty interesting. So it's like a live Postman, I'd say, which lets you explore your complete backend. But here it's not backend, it's your front end that you have. So you get a visual representation of the data that you're storing for your app. So making offline first apps becomes so much easier if you follow something like this. I'm not saying this cannot be achieved with Redux or Mob State. You can still have an initial state there and do something like this. But here with the documentation side as well as with the Explorer, it becomes a lot easier. And just because of the tooling, it's nothing else. And if you happen to have a GraphQL endpoint, you can still use this. You can extend your GraphQL endpoint with extend, and whatever you want just on the front end side, you can just write the definition for those. And like I said, you don't really have to depend on a GraphQL endpoint. You can still call your endpoints of REST using this directive called REST. This is one directive that is custom and made by Apollo, and pretty much you can do everything that you can do with any other network client. So, and with having all the benefits. So let's talk about some stats. There's a app called GitHunt app. GitHunt is app which is used by Redux on their official GitHub repository to showcase the ideal usage of Redux in a real world app. So if you look at it, there are some stats on that. There are around 16 files. There is around 700 lines of code. Yeah. So, and this is what it looks like. There's nothing else. This repo just contains what is bare minimum for you to run a Redux on a real world scenario. So there's this lady called Daneman from Apollo. She created the exact same thing using Apollo client, and these are the stats. You just have 12 files, which is 4 files less, and the code is just 251 lines. So from 700, you have come to 251. So, I mean, we already know that Redux has a lot of boilerplate, but then this also reduces a lot of surface area for your bugs, for anyone's understanding, anything new that you need to add. This is what you get. So with GraphQL, you get just 30% of the code with what you were writing in Redux. So maybe experiment whenever you have time. And by the way, this also includes the types that were generated by TypeGen. So the 251 lines of code, 251 lines of code also included the types that could have been, that is generated by the CodeGen. So there's a CodeGen piece of it. We'll talk about that later if you are not aware. Just because we are writing everything in a typed format, it's completely typed of what I can query for, what I can resolve for. I can do a code gen for all the types that might be needed on the front end side. Let's talk about server side. Anything on the client side you want to ask? How is fragment different from? So fragment, like I said, so if you have to query for a user, let's say, and you need 2 queries on the single page where you are querying for user with exactly same attributes. It's just that you are passing something different, right? In that case, you would want to strip out the common pieces and create a fragment out of it that you use in both the queries. So it's only executed once and it cached on the Apollo client, and it gives you the result back every time you use it. So while the query is executed every time. So, it helps you save that bit of execution. It's mostly useful on the server side, but then since we are talking about the client side, I just explained that as well, sorry. Okay. Anything else on the client side? Nothing. Let's talk about server side. So at the root of all GraphQL endpoints is a well-defined schema. Without schema, there's nothing in GraphQL. There needs to be a schema which talks about at least 2 things, which is query and mutation. There's something else as well, which is called subscription, but I'm not covering it. It's completely part of your WebSocket connection. So, you can have streaming data there, but then since we're just talking about REST equivalent of this, let's just talk about query and mutation. And like we said, query is for get, if you want to think in that way, and then mutation is just for all your put, patch, update, any kind of other updation pieces. So in a schema, these 2 types are mandatory. These are object types for GraphQL. Without this, GraphQL cannot execute. So the other pieces are, obviously you can define your types, whatever is your domain. If your domain has users, your domain has comments, you can define all of them as types. Those are equivalent to this. Like here, you have a hero, you have a name. Okay, before I come to the type system, I just wanted to explain the types of the schema. So query and mutation are just 2 special types in GraphQL. You can define your own based on your domain. Like I said, for a user, for a post, for comments, you can say user has an ID, user has a name, user has email, and the types of it, right? ID is an integer type, name is a string type and all that. But then without query and mutation, GraphQL cannot do anything because these are the entry points for your query or mutation. So anything that you want to query, like a user, has to go inside the type of a query. We'll see how. But then understand there's a type system here. So since GraphQL is just a specification, there's no specific language that it says that you have to write your types in. It has its own type. It's called SDL. It's GraphQL Schema definition language, where you define the types you define the types of your data model basically. So if your domain covers 5 different data model entities, you just define the type of those. And just to dig deeper into this, hero and droid in the example is the GraphQL object type, while the name that is inside are the fields inside the type. And like the fields can have the very primitive types to it, which is string or integer or float or other things. Yeah. Okay. So this is what is the interesting part about GraphQL is the resolvers. So if you have a type of hello, and you can query for that, which is of type string, in resolver you have to write exact same thing for that particular type. So for hello, you have to write something which resolves that particular field. And for each field, you have to resolve it. Otherwise, GraphQL will not be able to execute any of your other pieces. And to do it in more detail, there are 2 important root type, which is query and mutation. That is like the entry point for your get or post that you can query for users here, which is of type user, and it's a array type, right? I mean, I can query for multiple users at the same time. Similarly, for mutation, there's a create user, where if I provide a name, it will create a user type for me. Yeah. And once you do that, once you provide a schema like this, the available options that you get on the front end is query and mutation, where you can query for users and again do a mutation like create user with the selection set of these 2 things. Let's talk about how the query execution actually happens. So if I had queried for user with the ID ABC and I had asked for ID and name back, so this is like a get query where you're saying myapi.com/user with the ID ABC, right? That's what I have made. This is a get call. So what happens is the first resolver, so I have to resolve for exact three things, right? Which is user, ID, and name. I have to resolve for these 3 things. If I have not resolved for these 3 things, GraphQL cannot give me a successful output. So I have to first resolve. So, and it goes, the execution steps are like this. It first resolves for user. When it tries to resolve for user, a resolver is written like that. What you are looking at it is parent arguments, and then there are a couple of more arguments to it, which is context and info. The parent is, since the GraphQL query can be nested, any of the nested parent is, any of the fields nested parent is what you get in the parent. Arguments is anything that you have passed in that, and then the 2 underscores, that which is not important here, I'll still explain, is the context and the info. Context is, consider context to be information sharing between GraphQL types, that if you want to pass any of the context for reading or writing to in the resolver, you can use that. And the last argument is info, which is AST representation of that particular query. AST is abstract state tree. It's interesting, but then it's mostly not used in most of the front end or back end development. So yeah, we are talking about how does the user is resolved. So user is, as the first thing that it has to resolve is the user, and consider that there is a function which is fetch user by ID with the argument of ID, that is querying your database for now. Yeah. So it is returning you a user with name Sarah and ID ABC. So that's what you get as soon as that resolver is called. Yeah. After that, it still has to resolve for the two other fields, which is ID and name. So that goes to the second level, and as nested this query might be, the more resolver levels it would be. So and once it goes inside ID, just because like we said, the parent would be the parent of the nested query. So here the parent already has a ID, so it automatically returns that. The parent already has a name, so it automatically returns that. Yeah. So you don't necessarily need to write a resolver for ID and name separately. If you have written it for the top level user, it automatically takes care of that because it infers just from the name and IDs. Yeah. The interesting piece here is the resolver takes care. So the same example, I'll refer back to it, that here it is making, so it is totally dependent on me, right? This fetch user by ID is my implementation. If it is connecting to a database, if it is reading from a file, it doesn't matter. It has got an ID and it is just reading from somewhere and just returning to me, correct? It just doesn't matter of what was asked to me, as in like as a client, did I ask for ID or name? I can ask for maybe email, I can ask for just the date of birth. But then whatever I have written in this function, which is fetch user by ID, determines the efficiency of my DB calls or how I'm fetching my data, right? And like I said, if you really want to customize it to not make extraneous database calls, you can get whatever was asked. Like in this example, ID and name was asked, right? You can get that value in the fourth parameter of your resolver, which is the info. It will tell you what was exactly asked. So you can write a variable database query saying variable whatever was asked, select variable 1, variable 2 from database and return me that, right? So the implementation control is still in your hands. Okay, so let's talk about how do we build it on the server side. I'm not sure if this is this visible till the back? It's not visible. What can I do? Yeah, I'm trying to zoom. I don't think this works. Just let me quickly check if I can do something. Is it any better? That didn't do anything. Little better? Yeah. So I'll still will talk you through this. So this is how you write in JavaScript. This was provided, one of the earliest implementation of GraphQL when it came out in public as an open source specification. There's something called GraphQL JS, which gives you this. You write everything as JavaScript objects. So there's something called GraphQL object. In that you provide a query, you provide the name, you provide the fields that it has inside it, and you're also resolving for it. So if you're writing without Apollo, of what Govinath has earlier discussed about, if you are not using Apollo, you can write the whole thing as just JavaScript. You don't need anything else. The problem with this is it's very verbose. You, in each of the field that you want to, like the user thing, anything that you want to resolve for user, you have to write the exact same thing. If you see for query of field user type as well as mutation of user type, it has those arguments, resolve. It just there are repetitive fields there. So this was the initial version of it. But then later, when Apollo came, there's something called schema first development. So people suggested that you don't have to be this verbose. It's very difficult to read and difficult to understand. We can do maybe better than that. So they suggested something like this. This is visible, yeah. So they separated out the schema definition with the resolving piece, right? So they said you first define just schema. Whatever is your use case, let's say you're making a e-commerce product, right? So what would the schema look like? Let's say everything is done. What would the schema look like at the end? You'll have a user with multiple fields inside it. You'll have a cart with maybe product that goes in, that takes in product. product will have multiple fields. There might be some payment options and things like that, right? So you can still define, but then it's just single page, right? Where you have defined all your objects and that matches exactly with your data model of whatever is in your data store, no matter which DB it is. It can be a MongoDB, it can be a Postgres, it can be anything. It can be Oracle, it can be anything. So the idea was to separate it out, just define what you're looking at here is type defs of user, saying user having an ID and name, and then the two important pieces that we talked about, query and mutation with I can query for a user and I can create a user, right? And then there are separate resolvers for that. So there is a query for a user and then mutation for doing this. So if I have these two things, I can build my GraphQL endpoint, right? So this is what Apollo suggested. So there are multiple advantages of this. It's completely readable. Your developers can talk to business by just with the schema, everyone can understand. Product guys can understand, front-end guys can understand. So it becomes a good communication tool for everyone. And schema is not afterthought. It's completely thought through initially that my product has these requirements. So it's supposed to also, let's say, have a Boolean field which says is status true or false, right? So you don't think it later and you don't change your multiple APIs to match for that particular field. And like I said, readability and it's fairly easy to implement as well because you are separately writing schema and just writing the resolvers for that to build it. And just because you are able to do this, you can obviously mock all of your resolvers with some mock data, which is providing for your type defs. But is that it? Is it really that way that it solves all our problems? GitHub's GraphQL API. So GitHub has a GraphQL API as well. They moved into GraphQL in 2016, I believe. They now have a V2 of it, which is 10,000 lines of code. So just the schema side of it, of what we are seeing here, right? User with ID and name. So that is 10,000 lines of code. So your schema might end up looking like this. I mean, this is just a random visualization, but then yeah. So when your app grows in complexity, is it really helpful? So there are some issues with the schema first approach. And this is what is being followed right now today. I mean, Apollo does that. There are multiple other clients or server, the way that you make in, at least in JavaScript side, everyone follows this thing called schema first development. So the major inconsistency will arise if you have a large team and everyone is working for their, let's say, own domain side or product. You'll start having inconsistencies in your schema and resolver. Just because the GraphQL needs schema and resolvers one-to-one mapped, otherwise it will not understand if there's something in your schema which says, I don't know, product, and it has one extra field which says is delivered or not. And if that has not been resolved in your resolver, it will just not work. Your whole GraphQL endpoint will not work. Even if you have the proper user schema as well as resolvers, it will just not work. So that's the biggest problem with this. Then other piece is you have to write that whole thing in one. How do you modularize this? And once you're modularized, let's say there is a product team which is just writing schema for product and resolvers for product. There is a consumer team which is just writing for consumer. So if they are writing in modular ways, how do you compose all of them and make sure that both of them are not using the same field names or there's no clashes there, right? So that's another issue. And then just because we have separated this whole thing out of schema definition in my own way, that where I say type user has an ID of type integer or name of type string. This is not really matching with any of my languages, right? JavaScript won't understand that, or even let's say Java won't understand that, because those are plain strings. I cannot make anything out of it. So I lose out on ID support as well as developer experience. This is completely typed. I can get autocomplete, I can get static analysis, I can get a lot of things, but I don't get that because of that schema first approach. And it's not like there are not solutions to this. There are a lot of solutions to this. For inconsistencies between schema and resolvers, there are plugins as well as tools that you can install in your IDE which make sure and prompt you if there is inconsistency, and you can correct those. For modularizing and composing, there are tools like GraphQL modules, as well as for composing there's something called schema stitching. For IDE support, again, there are plugins that you can use. But then are we actually fixing the problem, or are we fixing the symptoms? So we started from plain JavaScript object definitions for our server, where we said we can define that in proper JavaScript without any of the ecosystem binding of, let's say, Apollo or Prisma or anyone else. And when we ran into a problem, we found a solution which was fixing that symptom, not really the problem. So let's not do that. There's another approach that has been people are discussing about this recently. This is becoming quite popular, and if you see, this is also an approach that has been taken by Ruby. Ruby's static analysis was always there. They have never moved to a schema definition language. From the starting, they have been using the code first approach, where we write our types in the language that we are writing it for, all the GraphQL, and automatically any of the resolvers or the queries are automatically generated because everything is typed. You will see the examples of this. There's Hasura, there is Prisma, Prisma's Nexus is there. There's something called type GraphQL.js. They have implemented this where there's something called Graphene. Graphene has actually been there for long. If you use this, and let's say you have a Postgres database, all you have to do is connect a Graphene with your Postgres database. It will generate all the CRUD operations, the mutations part of it, as well as queries, without you ever writing anything else, because it understands the schema of that database, and based on that, it creates everything for you. So you don't really have to make sure that the types are matched with the resolvers or the queries. Like I said, this is already implemented in Graphene. Graphene is Python. GraphQL is Ruby. Sangria is Scala. Prisma Nexus is for JavaScript. Type GraphQL is also for JavaScript. These are recent, but then again, things come with a cost, right? Recently, Apollo announced something called Apollo Federation, which is a step backwards, saying schema stitching was never the right approach in a large organization. Federation is something that uses directives, the directives that we talked about earlier, but none of these code first approach yet supports directives. So you can still have a database from where everything is code generated for you from a GraphQL standpoint. But then if you want to move on to something like Federation by Apollo, that will not be supported, and which is not yet supported. It might be supported in the future, but that's the current state of it right now. So yeah, one thing I missed out on and why this piece is important in code first approaches, if you had seen the example, if you remember the example from Gobinath's slides, while you're making the GraphQL server, he was using for MongoDB, and that's true for any DB that you're using. You have to describe your data model separately for your DB, right? You're saying that user is of these types, and you write that in the type which is supported for MongoDB or Postgres or whatever you're using, right? So that there is that type definition that you do. Then you do a separate type definition which is for Apollo, right? So there is this duplication of types, and if there is any inconsistency in there, the whole thing breaks. And that's why this becomes a lot more easier, as well as so you can compare this with something. If you remember way back, there was something called Spring Beans in Java that you write in XML that will give you all your views based on what you have written in XML. So it's like that we have separated out the concern of, and no one uses Spring Beans these days because of the exact same problems. you write the code first approach, not really the schema first approach. Spring Beans can really help you, or the schema first approach can really help you prototype your whole app in a very quick fashion. But then when it grows, it starts to fall under the same issues that you always had. So yeah, that's all from my side. Questions? So authentication, right? Authentication comes a lot. Authentication, performance, caching, these things comes a lot with GraphQL. And this is not something which GraphQL should hold. GraphQL is not the implementation of this. Whatever you have been doing in your authentication, in your caching, in your performance, stays true for GraphQL implementation as well, because it's a layer on top of those, not for those. GraphQL doesn't do anything for authentication, doesn't do anything for caching. So whatever was your authentication mechanism, you can still keep on using those. That will not change. For your other question where you said GraphQL will do something to REST of what JSON did to XML. Yeah, so it's not like that. So if properly implemented REST API endpoints, I mean, REST again is a specification, right, which you have to implement in that way. If properly implemented, REST can also achieve the things that GraphQL promises for. I mean, separating out few things, like since it is not completely typed, you cannot have the type information upfront, but then still it can solve for a lot of problems. Plus, coming from a lot of years of development into REST, you have a lot of community support as well as a lot of knowledge which is required for you to build the applications as it is. While GraphQL is still new, there is a lot of issues that we haven't yet faced that we might face when we start doing this a lot more. Sorry. Okay. So yeah, and there's nothing in GraphQL side that you cannot achieve from the REST side as well. So that's what I'd say. It's not that REST is gonna die just because GraphQL has come in. REST has a lot of domain knowledge that people still are comfortable with and still want to use, and there's nothing wrong in that. GraphQL is perfect fit for a dynamic data organization which has to support a lot of clients, and if you are that organization, maybe GraphQL might be a bet for you. And again, it is on teams on how they pick it up. And like I said, there's nothing in GraphQL that you can't do with REST. There are different ways of achieving that, but you can still do those things as well. Yeah. So again, the database side doesn't change. So here you are just defining the types of it, right? You define whatever your data model is in terms of your domain of whatever it is. Whatever relational database that you have been using. So what are you doing right now? You make let's say a user query, right? You have a user API that you say myapi.com/user with ID, and in turn you are firing a DB call. Your server is firing a DB call, makes a connection to DB, gets the data from the DB, right? And that DB might have lots of foreign keys on that user table, which connects to lots of other things, right? That has nothing to do with how GraphQL will resolve for it. In the resolving of GraphQL, I resolve for a user type. And if in that case, if I have to make multiple database calls, I might have to do that. There are patterns in ways in which you can avoid multiple multiple database calls as well. But again, this is a complete implementation side, as in you can implement it in whichever way you want. There's nothing stopping you to use a relational database, just a NoSQL database, or maybe a graph database. You can have anything you want, and like I said, you can even read from a file that is on your server. I mean, it returns a promise, so it's like you can do anything. You can even telegram someone. Yeah, cool. Anything else? Okay, I'd also like to thank all of you guys. So GraphQL, like I said, is very new, right? You guys are the early adopters, or I mean, whoever is using it at this point in time, and you are the advocates for this. So, I mean, obviously at this point in time, you might face a lot of hurdles, you might face a lot of challenges, you might not find solutions for those, but then being early adopters would also help you in the longer run. There's a huge potential in where GraphQL is going with all the effort from Facebook as well as the Linux Foundation that is now uh, running this. So I'd like to have applause for you guys as well. Thank you. Yeah.